Good morning, everyone. My name is Dianarlet de León Saucedo, and I will introduce the subject, utilization of hydroxyapatite from Devilfish bone as biopolymer-based composites from the removal of fluorides and cadmium in aqueous solution. In this study, the hydroxyapatite biopolymer-based composites were used for the removal of fluoride and cadmium in water. The devilfish is an invasive species in the Huasteca Potosina of Mexico, which causes environmental impacts on the ecosystems and socioeconomic impacts. For this reason, the use of this species is proposed using its bones and biopolymers to attack the problem of water contamination with fluorides and heavy metals through absorption, as an alternative from the use of control of this species. The objective of this study is to synthesize absorbent materials from devilfish bones for the removal of fluorides and cadmium in aqueous solution as a management and control plan for the Loricariidae family. Starting with the extraction of bone from specimen collected in the Huasteca Potosina as a strategy for the management and utilization of the devilfish, using the bone compacts and biopolymers from the absorption of fluoride and cadmium in aqueous solution. Finally, to characterize the physicochemical and textural properties for the composites with higher absorbed mass, and in this way elucidate the absorption mechanism of fluoride and cadmium on the composite. The experimental methodology began with a manual cleaning of the bone and a hydrothermal treatment to eliminate fats and proteins, and then it was milled to powder. The synthesis of the composites was based on the ionic halation method, using alginate and chitosan as biopolymers, and calcium chlorine and sodium 3-polyphosphate as crossing agents. Absorption tests were carried out in batch with initial concentration of 400 mg per liter of cadmium and 80 mg per liter of fluoride, 0.1 mg of absorbent at a pH of 7 and 25 degrees Celsius constant temperature in a water bath. Finally, the characterization of the composite was carried out using different techniques such as nitrogen polyphosphation, active sites, FTIR, TGA, XRD, SIM, and EDS. As a result, we have that the maximum absorption capacities of fluoride and cadmium were observed in the composite based on hydroxyapatite and alginate polymeric matrix, with capacities of 7.64 and 106.59 milligrams per gram respectively. In these composites, there is a higher concentration of acid sites, a point of zero Sharp value of 6.36, and a swelling factor of 40.95%. Figure 1 shows the EDS analysis confirming the presence of fluoride and cadmium on the surface of the composites. Figure 2 shows the FTIR spectra of the composites and alginate, where the bands of carboxylate, phosphate, and carbonate groups were revealed. Here, Figure 3 shows the red and the percent weight loss curves, where it reveals that there is a loss curve where a loss of the organic phase of 200 degrees Celsius and a loss of the inorganic phase at 600 degrees Celsius. Finally, Figure 4 shows that the XRD spectrum belongs to the crystalline phase hydroxyapatite, the main inorganic component of bone. The absorption isotherms of the 1,5-HA composite were made at different pH from fluoride and cadmium, both conforming the Prauss-Radcliffe model. For fluid, the highest absorption capacity occurred at pH 5. Its absorption mechanism by electrostatic forces due to the pH being lower than the point of zero charge. In the case of cadmium, the highest absorption capacity occurred at pH 7, elucidating its absorption mechanism by ion exchange since cadmium replaced the calcium contained in the hydroxyapatites, and by electrostatic forces because the pH is higher than the point of zero charge. It is concluded that the use of this invasive species as an absorbent material is a potential alternative to the removal pollutions in water. Thank you all for your attention. Have a great day.